This is the Masking Handbook for Audiometry. In this video, we'll be taking a look at what it means to be overmasking. Here we have an unmasked air conduction hearing loss measured in the right test ear using TDH-style supraoral headphones. In the left ear, the non-test ear, the cochlear hearing is excellent, which is indicated by the bone conduction results on that side. Anytime we're completing air conduction testing, we need to be aware of the possible interoral attenuation characteristics. When presenting a signal, we have to be aware of when it might be able to cross over to the opposite side. An air conduction signal presented to this right ear will remain with the right test ear side, but only to a point. The amount that remains on the test ear side is quantified by its attenuation characteristics. For example, if we have an IA value of 40 dB or an attenuation value of 40 and deliver a 50 dB signal, then 10 dB of the signal will cross over to the non-test ear side. Attenuation refers to how much of the signal remains. Crossover refers to the level that gets across to the opposite side. The level of crossover and IA have a simple mathematical relationship to the dB test level of the presented signal. We typically don't know the real interoral attenuation, but we'll use minimum possible IA values to determine if masking is necessary. In this case, with a min IA value of 40 dB, masking would be necessary for the right air conduction threshold at 1000 Hz. However, if the real IA was 40 dB in this scenario, then the air conduction threshold responses would look something like this. Here are possible interoral attenuation values for TDH phones. Let's take a look at 500 Hz. Minimum possible interoral attenuation found was 40 dB. However, the maximum possible IA looks to be 75 dB. So that's the maximum amount of attenuation documented from the studies looking at attenuation. The average is about 55 dB. In this scenario, masking is necessary because the difference between the right air conduction threshold and the bone conduction hearing of the non-test ear exceeds what we know to be minimally possible. At the same time, we know the situational attenuation characteristics at 500 Hz is at least 55 dB. Let's consider the same scenario but reversed. We'll now consider the right ear to be the non-test ear and the left ear to be the test ear. If we're testing the left ear at 500 Hz and need to mask, we'll have to make sure that the masking noise is audible in the right non-test ear. It must therefore be fairly loud. Since our working IA value at 500 Hz is our SIT IA of 55 dB, and we introduce 15 dB of active masking to the non-test ear, the total masking level will be 70 dB. This means that 15 dB may cross to the test ear side. Since the bone conduction hearing is so good on that left non-test ear side, the masking noise may contaminate our testing. Don't forget, the crossover event happens via the bones of the head. In other words, crossover occurs via bone conduction. When this happens, it's called overmasking. Overmasking is most likely to occur when the non-test ear has poor air conduction hearing and the test ear has decent bone conduction hearing. 15 dB might just be a minimal amount of masking. An IML might have the occlusion effect compensation added in along with the active masking. If that's the case, the total would be 80 dB of effective masking level in total. In this case, we have a SIT IA value of 55 dB. There would potentially be a 25 dB crossover of the noise. So we're presented with a high risk of overmasking here. How do we determine the possible amount of crossover or the risk of overmasking? We use our attenuation values and subtract that from the test signal level. In formulaic terms, the risk of overmasking can be quantified in the following way. The risk of overmasking is present if the masking noise potential crossover is greater than the cochlear hearing of the test ear. The risk of overmasking is absent if the masking noise potential crossover is less than or equal to the cochlear hearing of the test ear. A high level of masking and a high amount of potential crossover alone do not automatically result in overmasking. Let's look at a different case. Here we have the same crossover situation with a high level of masking noise at 80 dB, except the cochlear hearing in the left test ear, as shown by our bone conduction results, is not that great. Our working IA value now becomes 40 because we must use minimum possible IA. With the same amount of masking noise, we now have a potential crossover value of 40 dB. However, we don't have to worry about overmasking. The test ear cochlea would not be able to hear the potentially crossed level of masking noise, even with this high level of possible crossover. The risk of overmasking then is determined by assessing the interplay between the intensity level of the masking noise, our working interaural attenuation value, and the cochlear hearing of the test ear. This is the Masking Handbook for Audiometry. If you liked this video, you'll love the handbook. For more resources on masking and to learn how to purchase the book, check out maskinghandbook.com.